So, this is the moon. It's pretty far away, but we still have a decent view of it from Earth. We've gazed at it for thousands of years, telling stories about it, wondering what it was and what it might be like to visit. In 1969, we found out. Turns out, the moon is more than just a glowing thing in the night sky. It's a real place. It's a landscape that you can stand on and explore. But it's unlike any landscape we have on Earth, because, well, it's not on Earth. And once you start looking around, you begin to realize just how strange it is. Imagine a bright, sunny day, brighter than you're used to on Earth. The ground is bright, the shadows are very dark, it's perfectly still and silent, and the sun is glaring overhead in a pitch-black sky. It's a weird thing to experience. All of this is happening because the moon doesn't have an atmosphere. There's no air to filter the sunlight or scatter it into a blue sky like it does on Earth. There's no air to carry sound and no air to protect you from the sun's full blast. But when you lose the air, you don't just lose the blue sky. You lose something even more unexpected: your depth perception. You may not know it by name, but your brain knows about depth perception. It's your ability to look around and instinctively know how far away things are. Our depth perception evolved here on Earth, and it works pretty well. But because it evolved on Earth, it sometimes depends on things we take for granted, like air. We need air to breathe, but air also helps us tell how far away something is. Take a look at these mountains. Somehow, you know that these lighter mountains in the back are farther away than these more richly colored mountains up close. What's happening here? Turns out, the mountains aren't all you're seeing. You're also seeing the air between you and them. See, air may not look like much, but it's far from nothing. It's made up of molecules and particles like nitrogen and oxygen, pollen and pollution, and water vapor. When light bounces off of these particles, especially water vapor, some of that light bounces into your eyes. It's like seeing a very faint cloud between you and whatever you're looking at. It doesn't make much of a difference when things are close, but the farther away an object is, the more air there is between you and it. And so, you see more of the air and less of the thing behind the air. It ends up looking kind of hazy. Your brain uses this haziness to make a general guess about how far away something is. But without any air in the way, it's a lot harder to tell how far away things are. This is exactly what happens on the moon. Because there's no air between you and everything you're seeing, views on the moon look crisp and clear all the way to the horizon. Things look clear, but also kind of flat, two-dimensional. They don't feel as far away as things do on Earth, and it can be somewhat disorienting. But what's the big deal? So what if you can't tell how far away something is? Well, imagine you're on the moon. It's your job to take a look around and explore. Because there's no air to breathe, you'll have to carry some with you. But your supply won't last forever. In fact, it'll only last a few hours. So before you set off to explore that hill in the distance, you need to make sure you have enough air to get there, check it out, and get back before you run out. And to do that, you need to be able to guess about how far away that hill actually is. But without an atmosphere, it's a lot harder to tell. And it's not just air. The moon is missing something else that also messes with your depth perception: familiar objects. Let's bring some telephone poles up from Earth to get a better sense of what's going on. Take a look at these poles stretching off into the distance. Your brain has a general idea of how tall these poles are because you've probably seen some like them before. To get us all on the same page, let's say they're about 15 feet high, the same height as a one-story building or three of you stacked on top of each other. Now, your brain also assumes that all of these poles are about the same size. This pole is 3 U's high, and so is this one. But wait a second. If they're really the same size, why does this one look way bigger than that one? Your brain knows the answer. The farther away something is, the smaller it looks. So, when you see a familiar object, like a telephone pole, your brain can guess how far away it is based on how small it looks. You can make an even better guess by comparing it to a familiar object nearby, like these other poles, or a building, or a person standing next to it. But there aren't any familiar objects on the moon. There's no buildings or telephone poles, there's just craters. And rocks. Lots of rocks. Rocks are familiar, but they can come in any size, from pebble to boulder. Take this rock, for instance. How big is it? Without something familiar to compare, you can't really tell. If you stood next to it, you might look this big. Or this big. What about that hill over there? How far away is it? If you were to walk over to that hill, you might look this big or this big. Either could be right. Without familiar objects, there's no way to know for sure just by looking. Some haze might help you guess, but of course there isn't any haze on the moon. Looking around, you realize how unfamiliar it all feels. But there is one familiar object you can see from the moon, and you know how far away it is because it's where you came from. The Earth. It's 240,000 miles away and much bigger than the moon in the night sky. It floats in a thin bubble of air, one that keeps us alive and helps give us some perspective. Back on Earth, with its hazy air and familiar surroundings, your sense of depth is restored. But there is one place on Earth where, if you look, you lose your sense of depth. Up. There's no air in space, so your view of the night sky is crystal clear for a very, very long way. And everything you can see is a real place, just so incomprehensibly far away that all you can see are pinpricks of light. We can see the moon because it happens to be our next-door neighbor. It's the first landscape we've seen beyond the Earth, but it may not be the last. There are a few other places in the night sky within reach. Mars, maybe sometime soon. And after that, Jupiter, with its own collection of moons. Think about that the next time you look up. What other strange, distant landscapes might we soon see?